Here we are again, Intro to Logarithms Part 2. Just so much fun. Let's get right into it. Oops, had to move that there. So again, here is a definition of a logarithm. Remember, this is called log form. And then this right here is going to be exponential form. Again, if I move too fast, pause me. It's your life. Live it. Pause me as needed. Special log. So we kind of talked about this on the last one. But log x is the same as log base 10 of x. So they kind of just, sneak that in there. There's also natural log of x, which is the same exact thing as a couple of things. So it's the same thing as if you wrote natural log e of x, which is actually the exact same thing as natural log or as log e of x. Alright, so just keep it in mind that there's an e here if you don't see it, and then if you have a log and you don't see anything there, it is a 10. So let's do this. Evaluate the following logarithmic expressions. So a couple ways you can do this, and I'm going to show you the way that we know so far. First thing, I don't know what this equals, right? So I'm going to say it equals x because I don't know what it equals. Now if we leave it here, we can go ahead and change it to exponential. So 3 to the x equals 27. And then you have to ask yourself, okay, 3 to what gives me 27? Well, let's break up 27 for a moment. 27 is 9 times 3, which is 3 times 3. Okay, so this is 3 to the third. I'm going to bring this down here. So if 3 to the x equals 3 to the third, notice that these match, so therefore these must match. So therefore x must equal 3. Okay, so this is all about matching. All about matching. So let's look at this next one. I don't know what it equals, so I'll say it equals x. Then I'm going to switch it to exponential form. So 125 to the x is 5. 125 to the x equals 5. I'm going to look at this here, and I mean, this is a real weird one because this is smaller than this one. So let's break up 125. So I know this is 5 times 25, and I know this is 5 times 5. Alright, so we have 5 to the 3x equals 5. Well, there's a couple things I want to point out here. Yes, these match, which is what you want, so therefore these match. But what's there? What is there? Think about it. 5 is 5 to what power? It's 5 to the first. So what this means then, let me scooch this down a little bit. What this means then is that 3x equals 1. We divide by 3 on both sides, and x is 1/3. Just like that. Okay, so it's all about matching. Same here. So this equals x. So 9 to the x equals 1. This one's tricky because you can break up 9 if you want, and you probably will. So you'll say 3 to the 2x equals 1. But again, these aren't matching. And here's why. Here's why. This one is a tricky one. So I'm just going to kind of cross this out real quick because that ain't going to help you. So this one is tricky. Remember this. Remember that any number to the 0 power equals 1. So therefore 9 to the 0 power equals 1. So x must be 0. So this one's definitely tricky. Remember, any number to the 0 power is 1. So 9 to the what gives you 1? It must be 9 to the 0 power. Here we're going to say equals x. They are trying to be tricky here because remember they wrote nothing here, so you got to know there's a 10. So 10 to the x equals 10. 10 to the x equals 10. Now these match, but again you have to realize there's a 1 right here. So we've got our 10s matching, and we got this matching, so x equals 1. Okay, so it's all about matching game except for the tricky one, which kind of stinks. Let's do this down here. Now they already got it set equal to x for you. I think this might be a little easier, although 6 and 7's looking a little crazy, so we'll talk about it. So 2 to the x equals 32. Alright, let's break down 32. I know that's 2 times 16. I know this is 4 times 4. And this is 2 times 2. So that's 2 to the 5th. So 2 to the x equals 2 to the 5th. And we got some matching going on right here. So that matches, and that matches, so x equals 5. Remember, you can always pause this if I'm going too fast. It's all about you. You do what you need to do to get the right grade, okay, and to learn. So this is 3 to the x equals this. So 3 to the x equals 3 to the negative 0.9. This already matches. The 3's match, and then check this out. Those match. So automatically, x equals negative 0.9. So that one actually wasn't that bad at all. Let's take care of number 7. So 1/3 to the x equals 27. Now this one's going to be a little different. You do want to break up 27. There's going to be a little bit more to it than that, but we're going to start by breaking up 27. So that's 3 times 9, and that's 3 times 3. So we are going to have 1/3 to the x equals 3 to the 3rd, but notice that 1/3 and 3 don't match. Let's take a side journey. Remember back in the day, if we had 1 over x, this is the same thing as x to the negative 1. Let me give you a different example. 1 over x squared is the same as x to the negative 2. Because remember, you would take the negative exponent and you would just put it on the other side of the fraction. So therefore, 1 over 3, wouldn't that be the same as 3 to the negative 1? Those are the same, right? So in this problem right here, we have 3 to the negative 1x equals 3 to the 3rd, and then we start matching stuff up. So these 3's match, and then negative 1x and this 3 match. So then we've got negative 1x equals 3, so x equals negative 3. There you go. So that one was a little bit more complicated. You might want to rewatch that one. Down here on this, remember there's a 10 here. They're trying to be sneaky. 10 to the x equals 10. 10 to the x equals 10. Again, they're trying to be sneaky. We did one like this earlier. It does match up, but you got to know that there's a 1 there. All right? And then once you know there's a 1 there, you can see x equals 1. Again, if I'm going too fast, pause it. Do what you need to do. We're going to take care of this one. So 5 to the x equals square root 5 to the 4th. Okay, well let's discuss this. Let's go on a little side journey again. Remember back in the day when I'd have stuff like this? Y'all would tell me this is to the 2/3, right? The root goes in the denominator, right? So like if I had square root y to the 4th, remember this is a square root. This would be y to the 4 over 2, which I guess is essentially y squared, right? So same deal over here. There's a square root here. So that means 5 to the x equals 5 to the 4 over 2. Let's fix that up. So 5 to the x equals 5 to the 2nd. I think you see it now, right? It matches up. So those guys right there go together. So x equals 2. Oh, goodness gracious on this next one. Okay, so it's 7 to this whole thing equals 49. So 7 to the 5x plus 3 equals 49. So I'd break up the 49. It's 7 times 7. So 7 to the 5x plus 3 equals 7 to the 2nd. The 7's match. The exponents match. So then what we're going to do is we're going to have 5x plus 3 equals 2. Going to subtract 3 from both sides. So 5x equals negative 1. Then we're going to divide by 5. So x equals negative 1/5. Woo, and there you have it. You might want to rewatch this one. I'm not going to lie. You might want to rewatch it and really know it because this is a little bit tougher than yesterday. And until next time, goodbye.